Assalamualaikum and good day to everyone. Today we will discuss calculus topic, which is differentiation. But before that, ain't that a great video? Let us introduce ourselves properly. My name is Zulazmin.
My name is Zafran.
And my name is Tahfiz.
Alright, without further ado, let's start with the definition of differentiation. What is differentiation? Well, it is a fundamental concept in calculus dealing with the rate at which a quantity changes. It is process of finding the derivative of a function, which provide information about the slope of the said function at any given point. Now, let's talk about the techniques of differentiation. There are 9 techniques of differentiation. First is power rule. It is used to differentiate power of x. Second is constant rule, where the derivative of a constant is 0. The third is quotient rule. It will apply when one of the function is divided by another. Fourth is chain rule. Used when a function is inside another function. Fifth is product rule. It can be applied when two functions are multiplied. Sixth, the trigonometric rule. It can be applied for differentiating sine, cosine, tangent, and others. Trigonometric function. 7 is exponential rule. Applied for exponential function. 8 is generalized power rule. It is extension power rule when base is a function. Lastly, the logarithm rule. It used for differentiating logarithmic function. Now that we finish with the explanation of techniques, let's test those techniques to questions, shall we? Question 2a. The question is y equal to e to the power of negative 2x multiplied by the quantity negative 6x plus 1. This question we will be using product rule technique. First, let's make u as e to the power of negative 2x. Now let's derive e to the power of negative 2x and make it into u prime, which is equal to negative 2 times e to the power of negative 2x. Now our v is equal to 3x plus 1 and derive it is a 3. Now let's make the full equation of dy dx, which is using u times v prime plus v times u prime. So it is e power of negative 2x times 3 plus 3x plus 1 times negative 2e power of negative 2x. We simplify it, so now dy dx is equal to e power of negative times 2x multiplied by negative 6 plus 1. Now to the question 2b. The equation is y equal to square root x plus sine 3x. This question using the power rule for square root x and trigonometric for the sine. Let's change square root x into x power of 1 over 2. So we able to use power rule. Sine 3x will become 3 times cos 3x. And the answer will be dy dx equal to 1 over 2 times square root of x plus 3 times cos 3x. Now I have talked about the definition, technique, and question 2. Zafran will continue this conversation by explaining how to do the question 3.
Thank you, Zul. Let's start with the question 3. The question give an equation is not explicitly expressed in the term of x. This is called implicit function. We will be using the implicit differentiation. The equation in the question is e power of a 2y plus 2x equal to y power of a 3 plus cos 4x. Let's derive all that in the equation. It becomes 2 times e to the power of a 2y dy dx plus 2 equal to 3 times y to the power of a 2 dy dx minus 4 times sine 4x. Let's rearrange where y on the one side while the x on another. The new equation will become 2 times e to the power of a 2y dy dx minus 3 times y to the power of a 2 dy dx equal to the negative 4 times 4 sine 4x minus 2. Let's factorize the y side, and it will be dy dx times 2 times e to the power of a 2y minus 3 times y to the power of 2. Move time 2 times e to the power of a 2y minus 3 times y to the power of a 2 to the x side. The new equation and the answer will be dy dx equal to negative 4 times sine 4x minus 2 over 2 times e to the power of 2y minus 3 times y of the power of 2. That's it for the equation 3. The last equation will be explained by Tafis.
Wow, thank you Zafran. Now I will explain about the last question. This question will be using linear approximation, and it is to estimate the value of the function at a point near a known value. The question is fx equal to 1 divided by cube root of 124.99 plus the cube root of 124.99 power of 2. Let's change 124.99 to x so it don't distract us to derive. So the equation will become fx equal to 1 divided by cube root of x plus x power of 2 divided by 3. Our x is 124.99. We will choose a new number that nearest to the x, which will be 125. Let's find the differential dx, which is 124.99 minus 125, where we will get negative 0.01. Let's find our f prime x. Our f prime x equal to negative 1 divided by 3x power of 4 divided by 3 plus 2 divided by 3 multiplied by x power of 1 divided by 3. Let's change 124.99 into 125 in fx. So it will be f in bracket 125 equal to 1 divided by cube root 125 plus 125 power of 2 divided by 3. We will get 125 divided by 5 or 25.2. So let's use the linear approximation formula, which is fx approximately equal to f nu x plus f prime nu x multiplied by the differential dx. So it will be f124.99 approximately equal to f125 plus f prime 125 multiplied by the quantity 124.99 minus 125. So let's add the number into f, which is 126 divided by 5 plus the quantity negative 1 divided by 3 times 125 to the power of 4 over 3 plus 2 divided by 3 times 125 to the power of 1 over 3 multiplied by negative 0.01. So the final approximately result is 25.1987.
We have explained the definitions, techniques, and questions related to the differentiations. Differentiation is a very important topic in calculus. In fact, it's used in the real world, such as a min, max, cost, and profit, weather prediction, bridge, and rocket. So we must be able to do differentiation questions. That's all for us. Thank you for watching.